In this lesson, we'll solve two important CBSE questions using trigonometric identities. While solving these questions, don't try to remember the entire solution. Instead, learn how to recognize the pattern. Once you identify the correct identity, the calculations become very simple. Let's begin with question 1. We need to prove that 2 into cosine pi over 13 into cosine 9 pi over 13 plus cosine 3 pi over 13 plus cosine 5 pi over 13 equals 0. Before applying any identity, observe the angles carefully. Notice that 9 pi over 13 can be written as pi minus 4 pi over 13. This is an important observation because whenever an angle is close to pi, complementary identities are often useful. Now use the identity cosine of pi minus theta equals minus cosine theta. Therefore, cosine 9 pi over 13 becomes minus cosine 4 pi over 13. Substitute this into the expression. Next, recognize the product of two cosines. Apply the identity 2 into cosine A into cosine B equals cosine of A plus B plus cosine of A minus B. Here, A is pi over 13 and B is 4 pi over 13. So the first term becomes minus cosine 5 pi over 13 minus cosine 3 pi over 13. The remaining terms are already plus cosine 3 pi over 13 and plus cosine 5 pi over 13. Every positive term cancels its matching negative term, leaving only 0. Now let's solve question 2. We need to prove that open bracket sine 3x plus sine x close bracket into sine x plus open bracket cosine 3x minus cosine x close bracket into cosine x equals 0. Again, don't expand immediately. Look at the pattern. One bracket contains sine plus sine, while the other contains cosine minus cosine. This tells us to use the sum to product identities. First, sine A plus sine B equals 2 into sine of A plus B by 2 into cosine of A minus B by 2. Putting A equal to 3x and B equal to x gives 2 into sine 2x into cosine x. Next, cosine A minus cosine B equals minus 2 into sine of A plus B by 2 into sine of A minus B by 2. Substituting the same values gives minus 2 into sine 2x into sine x. Now substitute both results into the original expression. The first term becomes 2 into sine 2x into cosine x into sine x. The second becomes minus 2 into sine 2x into sine x into cosine x. Observe that both expressions are exactly the same except for their signs. One is positive and the other is negative, so they cancel completely. The final answer is 0 and the identity is proved. Always remember this strategy. First, observe the expression, then identify the pattern, choose the correct identity, and only then simplify. This approach saves time and makes even difficult CBSE identity questions much easier to solve.